two different factors, in a sense. Now, I like to put the perfect square first because it helps. The square root of 25 is a number. The square root of 25 is 5 because 5 times 5 is 25. And then we have the square root of 6 that's left over. Now, let's see if we could break down the square root of 6 some more. Factors of 6 are 6 and 1 and 2 and 3. And none of those are perfect squares. So I know this is my final answer. 5 radical 6. Let's look at the square root of 180. Again, first, let's find the factors of 180. You think of some factors. Maybe there's 60 and 3. True, none of those are perfect squares. You keep going. 30 and 6, not a perfect square. Keep going. 90 and 2, not perfect squares. Keep going. 9 and 20. Ooh, 9 is a perfect square. All right, let's see what else we've got. Maybe 10 and 18. None of those are perfect squares. So I'm going to try and go with my 9 and 20. If I do that, I can break this apart. It's always freezing, but you're taking a test. Don't let everybody online know you're taking a test, girl. The square root of 9 and the square root of 20. The square root of 9 is a perfect square. The square root of 9 is 3. So I know that this is 3 as a whole number. And then we have the square root of 20. I could be done, but I'm not sure. I always want to try that second number just to be sure. All right. So now I'm going to look at the 20. Factors of 20, 10 and 2. None of those are perfect squares. What else we got? 4 and 5. 4 is a perfect square. So the 20 can now be broken into the square root of 4 and the square root of 5. 5 times 4 is 20. I already had the 3. So I still have my 3 out here. And it's 3 times the square root of 4 times the square root of 5. Well, what is the square root of 4? It's 2. So now we have 3 times 2 times the square root of 5. My final answer is 6 radical 5 when I simplify it. To be fair, Miss Reed, or you, if you knew up here that you had 180 could be factored into 36 times 5, then you would have saved this extra step. But if you don't, you just continue to simplify all the way. Now you go ahead and try number 3. Pause the video and try number 3 on your own. Um, 160 was broken into 16 times 10. So I brought this into 16 and the square root of 10. The square root of 16 is 4. So then we had 4 radical 10. I'm going to try out the 10 over here. That's 2 times 5 and 10 times 1. None of those are perfect square. So this is as far as I can go when it is simplified. Now the perfect cube is going to behave in a similar way, but make sure you're using your perfect cube, a number times a number times a number. So first we see here that we want the cubed root of 16. I'm going to find the factors of 16. Oh, let me do the cubes in a different color. Orange. So factors of 16, I do have 16 and 1. I have 4 and 4. And then I see that these are perfect squares, not to be confused with your perfect cubes, because now we're looking for, again, the cubed root. So that's not a perfect cube. That's not a perfect cube. Maybe we have 8 and 2, and then we see that 8 is a perfect cube. So the 16 I can break into the cubed root of 8 times the cubed root of 2. And the cubed root of 8 is a number. It's 2. And then I have cubed root of 2. So now I can look at the factors of 2, which is just 2 and 1. I know I can't break that down anymore because 2 is not a perfect cube. And so I am done with this simplifying. I'm going to try number 5. Let's get the hang of it. And that's 192. So again, factors of 192. Let's see what we got. 8, 64 and 3. 64 and 3. So if I look, I think that's it. 64 times 3. 64 is the cubed root. And so I have the cubed root of 64 times the cubed root of 3. And then cubed root of 64 is 4. And the cubed root of 3, I cannot do. Let's see. 3, oops, just 3 and 1. And that's not a perfect cube. So then it's the cubed root of 3. And that's my final answer. Go ahead and try number 6 all by yourself. Pause it and try it. All right, so when you are done, you should have 5 and the cubed root of 2. All right, so this gets broken into the cubed root of 125 and the cubed root of 2, because the factors of 250 was 125 and 2. All right, now let's talk about multiplying. How do we multiply them? When you multiply radicals, we're going to multiply the numbers first. Then we're going to multiply underneath the radical. Just like before, we're also going to simplify. All right, it can be done in a mixed order. So let's look at number 1. Number 1 is here. I have 2 radical 2 times 3 radical 2. I'm going to multiply the numbers first. 2 and 3 are the numbers in the front being multiplied. Everything is being multiplied. That's why I could do the numbers first. So 2 times 3 is going to give us 6. And then I'm left with these radicals. Well, to multiply radicals, I multiply underneath the radical. Let me give that a different color for you. I multiply underneath the radical. So 2 times 2 is going to give me the square root of 4. Can I simplify that? Yeah, because now I know the square root of 4 is a number. It's 2. So now I have 6 and the square root of 4, which is 2. And 6 times 2 is 12. Let's see it again. In this case, I want us to see it, but I also want us to look at it. I have 4 times the square root of 3 times the square root of 4. Now, if I'm going to go 4 times 1, maybe I could do that, but let's go ahead. 4 times 1, because if I don't see the number, it's because there's only 1, 4. And then I'm going to multiply underneath the radical, 3 times 4. And that's how I'm going to get the square root of 12. Then I'm going to go ahead and simplify this. Well, factors of 12, 3 and 4, 12 and 1, 6 and 2. Any of those perfect squares? Nope, nope. Here, the 4 is a perfect square. So I'm going to break apart the 12 into the square root of 4 and the square root of 3. 4 times 3 is 12. Square root of 4 is a number. It's 2. So I have 4 times 2 times the square root of 3. And my answer is 8 square root of 3. I want to point out another way, because if I notice the square root of 4 from the beginning, I could have just said this is 4 square root of 3 times 2, because the square root of 4 is a number, it's 2. And in that case, I would still multiply the numbers first and get 8, and then I would just have the square root of 3. Same answer. It depends on what you saw first. All right, so here we go. We are looking at number 3. I think I'll let you try it. No, I think I'll try it with you. I'll pause and try number 3. Now that you have paused and completed number 3, you're going to numbers first. That means 8 times 3 gets multiplied, and we are going to have 24. Then you multiply under the radical. So 5 times 8 is going to give us the square root of 40. I could be done, but let me see if I can simplify the 40. How do we get 40? There's 20 times 2. And there is 4 times 10. I'm trying to get some other ones beforehand. Oh, and there's 40 times 1. Oh, there's also 8 times 5. Well, I just did that, so 8 times 5. None of these are perfect square, not perfect square, not perfect square. Here is a perfect square. It's 4. So then we would have 24 times the square root of 4 times the square root of 10. And also feel free to fast forward me. You could put me on 1.5. You could make me speed up and put me on 2. Whatever you delight in. So now we have 24 times the square root of 4, which is 2. And then we have the square root of 10. Well, 24 times 2 is a number. It's 48. So we have the answer, 48 times 10. Let me see if I could break down 10 some more. It's 5 and 2, 10 and 1. Nope, nope. None of those are perfect square. And the more you do it, you will realize as well that the some numbers, you'll begin to recognize those that are simplified all the way. Right? All right, let's look at the cubed root. These are very similar concept. First, you multiply the whole number again. So we get 20. And the cubed root of 36. Well, I know my 20 is there. Let's see if I can simplify the 36. Always try. That's 36 and 1. 36 is not a perfect cube. We have 4 and 9. Not a perfect cube. Perfect squares, but not perfect cubes. We have 6 and 6. We have not a perfect cube, not a perfect cube. 2 and 18. None of those are perfect cubes. We have 12 and 3. Not a perfect cube. And I think I've gotten them all. But because there's no more, then I am done. Go ahead and pause. See if you could try out 5 and 6. Pause the video. Remember, the only way to learn math is to do math. Is it a technological question? All right, so then we would, hopefully we did 3 times 4, and we went ahead and we had 12. And after you had 12, you multiplied underneath the radical and you realize, oh, it's 36. But I just got 36 and I know it can't be simplified, so I am good. Then I would come over here, 2 times 3, you had 6. And then underneath the radical, you would have the cubed root of 50. And I didn't intentionally go that way, but this is 25 and 2. This is 10 and 5, 50 and 1. How's it 50? And none of these happen to be perfect cube. I'm actually done. All right, so that's how we multiply.